Welcome. Welcome to Science 8 class tutorials. Good day, class. I am Teacher Juna. I would like to congratulate you for completing or passing your modules or self-learning kits in quarters 1 and 2. Now you're ready for the third quarter. Today, we will discuss the contents found in your SLK for weeks 1 and 2. So today, our lesson is about particulate nature of matter. Matter is made up of tiny materials known as particles. This was conceived by Democritus, a Greek philosopher. He was able to term the word atom, which came from atomos, a Greek word that means indivisible. Now, matter may exist in one or more forms, depending on its composition and the condition of its environment. Let's take for an example, a rock. Now, if it is in a room temperature, the rock is in solid form. But when it is under a volcano or beneath the earth, then the rock is in liquid form. This will then be called magma. Also, the form in which matter exists is important and it is affected by its properties. Example here is a dry ice. If you look closely, this is being heated up and it doesn't melt like any normal ice. Instead, this dry ice from its solid form becomes a carbon dioxide gas. Now this process is called sublimation. How do we describe matter? So these are simply described through its properties, which is the characteristics of matter. The mass, it is the measurement of the object that has mass. And the volume, which measures the space occupied by that object. So in summary, matter is anything that occupies space and has mass and volume. It is composed of tiny particles called atoms. No matter how do we define or identify matter from non-matter? So all you need to remember is that non-matter are things that do not have volume or mass, and it does not occupy space. Let's take here on the screen an example of matter, and here is the example of non-matter. Alright, let's proceed. Right now, I'm going to give you your first activity. Which is which? I need you to identify which do you think is matter. You are going to answer it on your answer sheet provided in your self-learning kit. All you need to do is to put a check under the appropriate column and write the reason to explain your answer. Alright? So, if you think you need more time, I need you to pause this video and then just play it back once you're done answering. Okay? Good job! You are done with your activity. So, let's proceed with the lesson. If you must remember, I have mentioned a while ago that matter has many forms. So, let's try to identify each forms of matter, or the stages or phases of matter. We call it the 5 states of matter, which are solid, liquid, gas, plasma, and the newest in the crew is the Boise-Einstein condensate, or we call it the PEC. We are going to talk about the contributors in identifying the 5 states of matter. It first started with Democritus. Just pull up my laser here. Just give me one quick moment, and then here. So Democritus in 400 BC or before Common Era was able to identify atoms, and this led to identifying which is solid, liquid, or a gas matter. And then it was followed by Sir William Crookes in 1879, which is already under the Common Era. He was able to discover plasma. On 1925, Satyendra Nath and Albert Einstein collaborated in predicting BEC, which then led the three scientists to make further study about this BEC. They were Eric Cornell, Carl Wieman, and Wolfgang Kepler. And in 1995, their studies were acknowledged about the BEC, and they even received a Nobel Prize award in 2001. Now let's go ahead and try to identify these 5 states of matter one by one. Let's go ahead and start discussing about solids. If you can see here, there is an ice cube, an apple, or a car. Now, you just need to remember that solids are usually hard because their molecules have been packed together. And the closer the molecules are, the harder the solid is. So solid holds their own shape. So showing here is how the pattern or how the molecules of solids are packed together. Now, since they are tightly packed in a regular pattern, sometimes it vibrates, but they do not move from place to place. So this is solid. Next is liquids. So liquids here, we have examples like coffee, water, and a soda. Remember that liquids will fill up the shape of its container. Okay? Water and blood, or your blood, is a liquid. And liquids are in between state of matter when they can be found between solid and gas. If you can see here, the molecules of liquids are moving in this way because they may be close together, but there is no regular arrangement. So they still vibrate and move about, and they can slide past each other because their molecules are not as close as what the solids have. Alright, this is liquid. Next, we have the gas. So gases, examples are air molecules, combustion, and the air balloon. Here, gases can fill as well. Like the liquids, they can fill the containers of any size or shape. The gases are really spread out, and the atoms and molecules all are full of energy, and so they are bouncing around constantly. So this is how we see the molecules of the gases. And since they are well separated and no regular arrangement, they also vibrate and move freely at high speed. So this is gas. Next is we have plasma. If you can see here are the examples of plasma. We have the aurora borealis, the lightning, the plasma ball, the nuclear fireball, the neon signs, and the welding arc. Plasmas are made up of 3 electrons and ions of the element. You see plasma when you look at stars because the stars are big balls of gases at really high temperatures. Now looking here in the physical model, you can see the proton beam passing through the plasma because they don't have definite volume or shape, and is compressed of electrical charge particles. So this is plasma. Next, last but not the least, the Bose-Einstein condensate, or the BEC, which are a gas-like state of matter that exists at extremely cold temperatures. It was predicted in around 1925 and confirmed in 1985. What you see here is that they look alike, but they are actually different kinds of atoms here. Now, when the atoms get cold, because you will reach, once you reach the 0 Kelvin, these atoms begin to clump up, and once they clump up, they become one big blob that they all look the same. So if you notice here, this is the temperature and this is the energy. So as the energy is added, it becomes hot. But if the energy is taken, it becomes colder. So if you can see, these energies are taken away. That is why these are the reactions of the atoms. They clump up and forms a blob. So this is the BEC. Now, how do we identify the properties of matter? So matter has two major properties, the physical property and the chemical property. We will be able to categorize it identify it if the substance can still be identified after changing. It will be under the category of physical property. While if the substance changes its property, it will be under the category of chemical property. This can be further explained by its reactivity, flammability, toxicity, ability to oxidize, and heat of combustion. Going back to the other category of physical of matter's property, which is the physical property, it is subdivided into two as well: the intensive property and the extensive property. All you need to know is that one type of property, physical property, has it depends on the amount of its substance, so it is measurable. So under this is it is under the extensive property, which will measure the mass of an object, its volume, and the weight. But if it does not depend on the amount, it will fall under intensive property, which will further describe or study the density, the color, the luster, the odor, the moldability, conductivity, hardness, ductility, and boiling point and melting point of an object. Okay, it will fall under intensive property. So this is how we are able to describe the object or the type of matter of this object. We have come to the end of the lesson. Bravo, class, for completing this lesson. I just need you to please answer the activity 2, evaluation, and the additional reading activities found in your self-learning kits for weeks 1 and 2. Now it's your time to shine.